Hi, I'm Angela Abbs, and this is measuring the size and age of our universe by looking at the oldest star, and two, by measuring the rate of expansion of the universe and exploring back to the Big Bang. The ancient star formed not long after the Big Bang, which is 13.8 billion years old. This is the oldest star that was created long after the Big Bang. Now, another way of measuring and getting our age and measuring our universe is called the globular cluster. Roughly 1 million stars. Presumably, the universe itself is at least as old as the oldest globular cluster that resides in it, and this is the cluster. Now, there's three steps that the astronomers use to measure the universe rate, the expansion rate, the Hubble constant, which is used to measure accurate distance of galaxies near to far from Earth. This is the stellar parallax, and this is the old parallax limit, and this is the new parallax limit, and the light redshift by expansion of space. Another alternate approach to estimate the age of the universe is measured the Hubble constant. The Hubble constant is measured the constant expansion rate of the universe. This is the Hubble constant. The WMPA fact was a mission revealed conditions as they existed in the early universe by measuring the property of the cosmic microwave background radiation over the full sky. The microwave radiation is released 375,000 years after the birth of the universe. The universe was born with a Big Bang. Because of the Big Bang and the oldest star, we are able to measure the size and age of our universe. And this is my reference. Thank you.